All right, so 6.1, discrete random variables. A random variable is a numerical measure of the outcome of a probability experiment, so its value is determined by chance. It's a random variable. Give you guys a chance to write that. All right. They are typically denoted by using capital letters. I'll pause right there. Well, should be able to go up some, right? Of course, if I go up too fast, always let me know. You still copying? Mhm. Discrete random variable has either a finite or countable number of values.
Can you go back up to random variable?
Mm-mm.
Uh,
Yeah, right there. You, I know.
Hey.
Uh, so let me know when you finish. I'll scroll it down.
I'm finished with this one.
All right. So a discrete random variable has either a finite or countable number of values, can be plotted on a number line with a space between each point. So just an example of what you're talking about as far as being plotted on a number line. In other words, when it comes to discrete random variable, it is what it is. If the number is 5, then it's 5. If it's no such thing as 5.1 being a legit answer. It's countable. It's like you can just put if 5.1 is the answer, then there's no other answer. You see what I mean in a second when we look at the next example. Countable means you can put a number on it, and then that number is what it is. There's no other fluctuation between what it possibly could be. When you look at continuous random variables, though, has infinitely many values, and most of the time that comes in when you talk about measurements. So let's say if we're measuring weight, and if your scale is more accurate than mine, that doesn't mean my answer is wrong. If mine go to 5.1 and yours go to 5.12, both of those answers are correct. It's just that yours is more accurate. So those type of values, especially when, like I said, when you talk about measurement, um, is where continuous random variables come into play. And like I said, it has infinitely many values, and it can be plotted on the number line uninterrupted in an uninterrupted fashion. So that means, if you're talking about between 0 and 1, everything in between 0 and 1 could be a legit answer, and so on. All right, scroll up. All right, so discrete or continuous. Trying to decipher between the two. So the first one, a number of A's earned in a section of statistics with 15 students. So that would be discrete. So either 5 people earned A, 7 people earned A, maybe only one person earned A. Whatever that number is, it is that number is countable, and there's no discrepancy between there's no such thing as 1.3 of a person made an A. So it's just one person made an A or 2 people made an A. Whatever it is, it's countable. When we look at the weight of a deli sandwich or a sandwich at the deli, that would be considered continuous because once again, we're talking about measurement. If your scale is more accurate than mine, then you will have a weight that will be more precise, wherein mine wouldn't be as such. But that doesn't mean I have the wrong answer, it's just that you have a better scale than mine. So most of the time, like I said, when you talk about measuring something, um, you're going to be looking at a continuous variable, excuse me. All right, the number of cars that pass through a McDonald's drive-through. That would be discrete. Once again, if you count 7 cars, then it's 7 cars. There's no discrepancy or um, difference in the two. The last one, the speed of a car that passes a state trooper is continuous. All right. All right, next thing we're looking at probability distribution of a discrete random variable x provides the possible values of the random variable and their corresponding probabilities. All right, so we have 2 rules for a discrete probability distribution. All right, first thing is that when you add up all the probabilities, they're going to equal to 1. Second one is all the probabilities should be between 0 and 1 inclusive. We talked about both of those distinctions before, or rules before. All right. So here we have 3 different probability distributions. It says which of the following is a discrete probability distribution. Let's copy those down. All right, so looking at the first one, remember it has to fit both rules. Remember they have to be in between 0 and 1 for rule 2, and then all of them have to add up to 1 for rule 1. So looking at the first one, I hit the wrong button. Hold up, what was that? Okay, there we go. All right, so the first one fails rule 2 because we have that negative 0.7. So all of your probabilities have to be in between 0 and 1. And of course, that's less than 0. So that fails rule 2. So A does not fit the discrete probability distribution. B fails rule 1 because when you add up all of your numbers, they give you 1.18 instead of 1. So questions on those first two. Once again, the first one fails rule 2. All of your probabilities have to be in between 0 and 1. The second one fails rule 1. All of your probabilities have to add up to 1. And then the last one, it passes rule 2 because all of your probabilities are in between 0 and 1. Now we have to add them up and see if they equal to 1. And if we do that, see that they do. And so C does represent a discrete probability distribution because it satisfies both rules. All right, any questions so far? All right, I'm going up. And make sure I got everything. Okay, so now, unless they may have changed the problem or two, but forgot whether they did or not. So when you go into my math lab, if they ask for the mean discrete random variable, you can just do like we did before when we talked about Googling that and then finding an app or website or calculator that can do it for you. Not going to hold you to the process. Same thing here. They ask for the standard deviation of the discrete random variable. If you Google that, a website or two will pop up and you'll be able to type in that information. Once again, I'm not holding you to the process of actually having to know how to find that out, whether it be the mean of the discrete random variable or the standard deviation of the discrete random variable. Once again, like we did before, use a website, calculator, or app to find those two, and you'll be fine as far as that's concerned. You just need something reliable in order to be able to find those answers. Questions on what we're saying here?
Not for me, no sir.
All right, appreciate it. So with that being said, that is the end of 6-1. So 6-2 we'll do next class. Once again, that's the end of chapter 6. So what I'm trying to do, you notice we really have time, so we could go over 6-2 and knock it out. But I'm trying to elongate the process because, at the end of 6-2, then we're looking at a test Let me see, did I write it down here? I must not have wrote it, okay.
Can you go back to number 2 for MML?
Yeah, hold on. Once I was looking for something that I written down. Maybe I didn't write it from other class. Well, I thought I wrote it for this class. I'll let you finish writing that before I look at another place.
Okay.
All right. I know I wrote it somewhere. Where did I write it? Oh, okay. Yeah, here we go. All right. So we're talking about test 3 for you guys. So we haven't done any test proctored yet. We did test 1 and test 2. And I just gave it to you on my math lab. So this test, we will do the proctored option. So here, that's going to be 3-4 for you guys. And that's going to be on Thursday. All right, so we're talking about 3-4 will be on Thursday, March 4th. So that's next Thursday. It'll be on chapter 5 and 6. For those who will be able to do it and take advantage of it. And you'll see what I mean by that in a second. Proctor, that means your cameras will be enabled. And make sure you bring your ID, because this is the same process that we will take on the final exam. You know, the final exam is not, optional or anything like that. So you would have to come to class, enable your cameras, show your ID to the camera so that we solidify that it's you. Sometimes people forget their student ID. So, if you bring some kind of ID that's legit, then and show it to the camera, then that will enable, solidify that it's you. And then I will give you the password. So now if you don't do as well as you like on this proctored test, I will create a makeup with the highest score that you can get on that is an 85, and which earlier 85 still doesn't stop you from getting an A out of the course if you do all of the rest of your homework and do everything that you're supposed to do. So, still a way to make it up if you don't do as well as you like. That option will open up after the test. So you will not see that now. But that option, that makeup option, will open up after the test day. All right. So this is how we're looking at the setup for the next few days. Except yours, of course, is Tuesday, Thursday. We did 6-1 today, 6-2 next class. Next Tuesday will be all review. I will not do anything new, but you guys will bring whatever questions you have. And then on the 4th, we'll do the test, which will be next Thursday. And these are the sections that the test is on. 5-1 through 5-4, 6-1, and 6-2. All right. Questions on anything that I've said? Anything? Everybody good? Everybody straight? So we got what, week and a half, almost 2 weeks? No, week and a half to make sure we're straight for this test. And yeah. And so of course, coming into this thing with the anticipation that you have been doing chapter 5 work and everything like that. So make sure, you're getting on the stuff. See if you have any questions. Next class, we're only doing 6-2. So if you have some questions that you want me to address before the weekend, you can bring them next class, because all we're doing is one section. And we'll go from there. Questions on anything. Make sure we're all right. All right. So if you don't have anything, you guys are good. I'm good. I will see you on next class. And take care. Have a good day.
Thank you. Have a good day.
Thank you.
Take it
Do the
easy.
same. Take care.
Bye.
All right. Take care. Thanks.